In this video, I'm going to solve indeterminate beam problems, and I'll use this example taken from YouTube, which is called slope deflection method, having one end fixed, other end hinged with shear force bending moment diagram, which is from All About Structural Analysis and Design channel. It costs 28 minutes to solve this problem with a V diagram at the end. And I've solved this in a quicker and more efficient way. And in this method, I will use a program called INUN to integrate different functions and help us to model the loads. And let me explain how we did this. And first, we could get two static equations by using this simple diagram. And here we could see that there's 3 points A, B, and C. And for A, it is a fixed end. And B and C is a pin support. And we could easily, let me change another color. We could see easily that they have a upward force hit. And we simply call this A, B, C. And for A, because it is a pin support, so it has a moment, and let's call it MA. And we could see a point load applied here, a 100 kN point load applied here at x equals to 2.5. And from x equals to 5 here at B and to the end at C has a distributed load 24 kN per meter here. So we could simply get this first equation by using only the upward force A, B, C, A plus B plus C, and the two applied loads 124 times 6 here, and equals to 0. And for E2, I will use the blue one to show E2. E2 is for the moment MA plus the moment B, which is B times 5, and C, the moment C, times 11, and moment by the two applied force, which is times 2.5 here, and times 8. And 8 means here the midpoint of the distributed load. And we could also get this one equals to 0. Okay, and then we could make a function, we call it Wx, that includes all the loads. The point load here, x equals to 2.5, and the point load here, x equals to 5, and the distributed load from x equals to 5, okay, to the end, this one. And we could simply get this Wx. And we could see it's like this. And these different symbols, we will use it when we type in our calculator. And then after we get E1, E2, and the W in the W function, we could integrate V, M, EIY prime, and EIY. And in the V function, we will know that the V naught is 8 here. And for M naught is negative MA, because here MA is anti-clockwise, which is negative. And then because it is fixed n at A, so EIY prime naught and EIY naught should be equal to 0. And then we will substitute x values, x equals to 5 and 11 into the equation EIY at B and EIY at C, which is x equals to 5 and 11 here. And then we could solve the equation for all the unknowns by these 4 equations. And then let's type the first equation. E1 equals to A plus B plus C minus 100 minus 24 times 6 equals to 0. Okay. And E2 equals to NA plus 5B plus 11C minus 100 times 2.5 minus 24 times 6 times 8 equals to 0. And then let's type our W, which is 100 times, and we could get this symbol here, a special symbol called small letter delta, x minus 2.5. Minus B times the same symbol, x minus 5 plus 24 times h, x minus 5. That means the distributed law from x equals to 5 to the n. And after we type W, we could simply get V function by integrate negative W by using our program and get this function. And the same method for getting the M function. And remember, the M naught should be negative MA. And that's 0 for EIY prime naught. And integrate M. Okay. And EIY should be integrate the EIY prime. And we could get this for VM, EIY prime, and EIY. And then we should substitute X into EIY now. And the first one is the EIY at B equals to 0, which is EIY and we put X equals to 5 equals to 0. And for the another equation should be EIY at C, which is X equals to 11 equals to 0. Okay. And we make sure that HX should be like this. And we could get the solution. And oh, type it wrong. And now we should get A, B, C, and MA. Oh, I forget to type this. Okay, and we could see that A equals to 41.6, B equals to 145 something, C equals to 56, and MA equals to 48.5. So we could now plot the VM diagram in the shape of YX. And don't forget to sub the solutions into the function. Okay, maybe let's just do it like this. Okay, and let's see if we could plot the V graph. And we should adjust the window setting. And let's put X maximum should be 20 and Y should be negative 100 to 100. Okay. And we could see we could easily get This one done. And let's plot the M graph too. And also we could adjust the window setting from -10 to 20. And for Y is -130 and 120. Okay, and we could see a shape like this. Okay, let's see. And we could see we have a similar shape here as the traditional solution that was done in the YouTube channel that is did by hand. And we could see that our answer is not quite same with the traditional version, because in this video he just round off some of the answers to 2 decimal places. That's not accurate enough, so you could see there's some error, but we still have the same shape here. And for the M diagram, we could see we also have the same shape as, okay, the same shape here. And to get the answer, if you want, we could choose to analyze the graph by finding maximum and minimum. Just like this. And you could see I use not more than 15 minutes to solve this example. Which is half of this video, which is almost 30 minutes. Although I think this innovative method by using calculator and the function INUN is quicker and more efficient and more accurate, because it rounds off the answers like this. Here for 2 decimal places or 3 decimal places. But there's something better than using this innovative method is when there's no calculator that can run this program, and we could only use this traditional method by a simple calculator. Like this. We could see that from the beginning to the end, this guy never used any program, just some kind of simple program. And he just used simple calculator to solve 2 unknowns or something. That's more easier to approach when we did not get a CAS calculator, or we could any integrate program. And it is suggested to use the most suitable way to solve this structural analysis problem in different situations, especially when you do not get a CAS calculator.